Hello folks, here is the second lesson for this week. We will now be jumping to one of the last units of the course, just to be able to not have to repeat myself if we go back to school. And that unit is going to be on probability. So what is probability? Well, definition of probability, the easiest one I could come up with is the likelihood that something is going to happen. And we deal with probability all the time in the real world, usually when we're dealing with gambling. So if somebody wants to go and get a lottery ticket, there is a certain probability of winning, which we'll talk about later. But one of the easiest probability experiments that we can do is flipping a coin. If you flip a coin, if the coin is properly weighted, usually there's an equal probability that you will get heads and an equal probability that you will get tails. And there are numbers associated to that. We usually say there's a 50% chance of getting heads and a 50% chance of getting tails, which we call the theoretical probability. If you flip a coin twice, there's a chance that you will get two heads or two tails. The idea is the more you flip the coins, the more likely you will end up with and by the way, that was called experimental probability. If you do an experiment where you only flip the coin a couple of times, that's an experimental probability, and it will not always match the theoretical probability. The theoretical probability is 50-50. That will only happen if you do the experiment basically a million billion times. But usually within a few hundred tries, you will start to see that that probability will be the correct one. So the likelihood that something will happen, this is used in sports, and I can show you an example of a type of question that you would potentially see. So in this case, we have, this is actually out of your textbook. So one way to predict future events is to analyze what has happened in the past. Suppose a baseball player has .250 batting average. Is she likely to make a hit the next time at bat? If there is a 20% probability of precipitation tomorrow, would you go to an outdoor concert? So those are some examples of probability, and we will come back to that. So if we look at, to start with our formula here, what is the formula for experimental probability? Well, the formula for experimental probability is the number of successes divided by the number of trials. And the easiest way to show that is with actually showing an example. So what is the probability of rolling a 6 when rolling a die 7 times? And I just realized that my screen is a little bit cut off here. Just give me 1 second. Okay, so what I did here is I actually used an online die roller. So this website here allows you to roll dice just with the click of a button, and you can change the amount of dice that are being rolled up to a maximum of 6. So I rolled it 6 times, and then I rolled it once more. So we've got 7 rolls here. So what is the probability of rolling a 6 when rolling a die 7 times? Well, we've got 1 success, which I wrote down here, out of the 7 rolls, which are number of rolls or our number of events. Okay, so if you look at the formula, number of successes over the number of trials, our trials are our number of rolls, which is 7, and our number of successes is 1. So the experimental probability, if we look at that formula, is 1 over 7. Now, in this unit, we're going to be representing our probabilities in one of 3 ways. we're either going to be representing it as a fraction, as a decimal, or as a percentage. So recently we've been working with percentages in our exponentials unit, and I showed you that if you're given a percentage, to convert it into a decimal, you divide by 100. Dividing by 100 moves the decimal spot 2 spots to the left. And if we want to convert a decimal to a percentage, we multiply by 100, which means moving the decimal 2 spots to the right. Okay, so those are the 3 different ways that we can discuss experimental probability. In the example of flipping a coin, our heads success would be 1, and let's say the number of times we flip the coin would be twice, right? So 1 out of 2 times we would get heads, theoretically, but experimentally that might not be the case. So what happens to the experimental probability the more you roll the die? Well, there is a way to check to see experimentally what happens the more often you roll the die, and we have to have a way of organizing that so that we can actually track it and see if it's matching what we expect. So the way we do that is usually by having some tables, and in the first table what we would do is we would just have our die rolls, and we would simply roll a die and write down what the result was, and we do that over and over again. And so this table doesn't finish. We could do it a certain number of times, and this is actually setting you up for an assignment that I'm going to be putting on the Google Classroom soon. So you can do this either with the web page that I just showed you, or you can do it with an actual die. And what you then do from that table is you create what we call a frequency chart. So a frequency chart is basically writing down what are all the results on the die from this table here. So we got a 2 on the first roll. I would put a tick in the 2 tally area. We got a 3 on the second and the third roll, so I would put 2 ticks on the 3. And you count this up with 1, 2, 3, 4, 5 in groups of 5. And then you just write the number here of each one. So you would do your table as many times as you need to. You would tally up all of your answers for what was the result on the die, and then you would write the frequency here. And then you can graph these results, or you can calculate the probability of any side of the die coming up by looking at how many times did a 1 come up and what was the total amount. And that's what the activity is going to be. So there's a worksheet that I'm going to upload to the Google Classroom. If you need a website to roll the die, if you can't find any dice at home, you can use this website here. There is a question where you're going to roll the die 10 times, and if we had been in class, I would have asked you to share your results with 4 other people, and that way you would have had 50 dice rolls. Because we're not in class, I'm going to ask you to either contact somebody from the class who's done the activity as well and share your results, or to actually roll the die 50 times. Yes, that's going to take a little bit of time, but it's also going to show you that with a little bit of patience, you can start to see results as to what they should be. And the question I would ask you right now at the end of this very short lesson that's going to lead into this activity is, what do you think the probability is to get a 1 on a die, or a 2 on a die, or whichever number up to 6? Each side of the die has a certain probability of showing up. What do you think that probability is? Now, your experimental probability won't be perfect, but it should start to get closer and closer to the correct answer if you do it, the more times you do it. So that's the end of today's lesson. It's a very short little lesson, just an introduction to probability, because you're technically supposed to do the activity, and from that activity we could discuss what the results were. Okay, we'll talk to you tomorrow.